What is the volume of the toy dinosaur? You see this a lot. They'll give you a graduated cylinder. One will show an object outside of the graduated cylinder. And then there'll be a second graduated cylinder. It's actually the same one, but it's later on. They drop the toy into it, and the water has been pushed up. You see right here. Now be careful anytime that you're given a scale. See what they're counting by. These are not counting by ones. This is not 4.1, 4.2, 4.3, 4.4, 4.5. These are counting by twos, or 0.2s rather. 4.2, 4.4, 4.6, 4.8. There's 5 milliliters right there. So this is actually starting at 4.8 milliliters. When you drop the object in, this is called displacement. The volume of the dinosaur is going to push the water up and out of the way. It displaces the water and it rises in the graduated cylinder. And however much it rises, that tells you the volume of the object that you dropped in there. So with these, the volume of the dinosaur is not 4.8, and it's not even going to be 5.2, 5.4, 5.6 here. It's actually going to be, you look at the volume, and it's going to be the difference between them. So it has risen up 2, 4, 6, 0.8 milliliters. All right, so that's my volume right there is 0.8 milliliters. Let's write this down real quick. So the volume is going to be equal to 0.8 milliliters, or you could put 0.8 centimeters cubed, either one. A centimeter cube is the exact same thing as 1 milliliter. One of these milliliters is 1 centimeter high, by 1 centimeter in width, by 1 centimeter in depth. That gives you a centimeter cube. They're equal to each other, and in fact, realistically, anytime you're measuring a solid object like a dinosaur, we would want to opt with the centimeter cube. Usually you use centimeters cubed for solid objects and milliliters for liquids, the volume. And since the volume that we're talking about is a dinosaur, we might want to opt for the centimeter cube. The second part of it says, if the dinosaur had a mass of 4 grams, what would be the density of the dinosaur? All right, you see a lot of these images going with density as well, because part of finding density is finding the volume, which we've already done. And they've given us the mass right here. The formula for density is density equals mass divided by volume. They've already given us the mass right down here. It's 4 grams. And the volume we figured out earlier up here, that's 0.8. And I'm going to put centimeters cubed, just because we are measuring a solid object. And then you just do the math. 4 divided by 0.8 equals to 5. And then you keep your units over here. You've got grams over top of cubic centimeters. That's going to be the unit for density. Grams over top of centimeters cubed. All right. So if I had an object that was, for every centimeter cubed, it's going to be 5 grams. So if I have 1 cubic centimeter of an object, it'd weigh 5 grams. If I had 2 cubic centimeters, it'd be 10 grams. If I had 3 cubic centimeters of that same object, it would be 15 grams. So it's 5 grams per cubic centimeter.